Good morning, 8th grade. This is Tuesday morning, and we are ready for lesson 3 in math. Puts your grade 8, lesson 3, light unit 809. You should be on page 10. And the title of the lesson is Counting Significant Digits. This lesson is not difficult, and yet you need to pay attention to some very important rules. So I put some board work on here, but before we do that, let me get started with just going down over the rules. So there are 6 rules. So just open your book to page 10. We'll look at the first rule, and I'll give you an example. Every non-zero digit in a measurement is significant. And what this is to just give you a concept of numbers that are important, really important in a digit. So any number, if you write it out, let's say I will use the number 529. All numbers are significant. So there are 3 significant numbers in this one here. So there's 3 of them. It's pretty easy. It's the 0 that gets us in trouble. But any counting number, 1 to 9, is a significant number, regardless of where it comes in your problem. So you have a couple examples there in the book. That's not, you have 3 of them. So let me go to the next one. At the bottom of page 10, it says sometimes zeros are significant digits. Sometimes they're just placeholders. Zeros preceding the first non-zero digit are placeholders. They are not significant digits. So what you have, any number you have that's got zeros in the front, let's say 2, 5, and it does not matter where the decimal point is. These zeros are not significant numbers. So you can put the decimal right here. Let's put it right there. You have 2 significant numbers. These 2 guys here. Any zeros in front. We could put as many as we wanted to. We can change the decimal. But the second rule tells you that any zeros in front of a counting number, this is called a counting number, any zeros in front of here are not significant. So you only have 2 that are significant in that. And again, you can look at your examples. Don't let the decimal throw you off here. Sometimes you think, oh, this is a significant. No, they are just placeholders. They're not important in the counting number. 2 and 5 are the only 2 significant numbers. Now go to the top of the page of 11. And the first rule says zeros between non-zero digits are significant. So anytime you have a number that has zeros in the middle, so if we could take this here number here, let me erase this here just a little bit, and we would put a 1 here. You could go ahead and put a decimal here, it wouldn't matter, but any 0 in between counting numbers, so if you would put like a 51, 5100. These are all significant numbers. So zeros in the middle of counting numbers, you have to count them. So let's count the significant numbers in this problem. 1, 2, 3, 4, 5, 6. There are 6 significant numbers in that problem. And again, look at your examples in the book. The next one, the second one from the top, is any 0 to the right of a non-zero digit in a number that contains a decimal point is a significant digit. Now, if I erase these here, it is saying the rule that you must follow if your number has a decimal point. Now this is tricky. This is the trickiest rule of all of them. But if you have a number that has a decimal point and you put zeros in It doesn't matter how many. Let's say we're going to go 59.00. You might think in normal life that these numbers are not important. The rule is, though, they are very significant in counting numbers. So you actually have 4 significant numbers. Any zero to the right of a non-zero digit, okay? This is a non-zero digit. Any zeros to the right that has a decimal point. If the number has a decimal point, that's the key. Right there's the key. If it has a decimal point, any one to the right are counting. So again, you have to count all of them. 1, 2, 3, 4. There are 4 significant numbers in this problem. This is a tough one, so let me give you some more examples. If you have 21, 0, 0, and let's say we put the decimal point right there. Again, you will need to count these zeros. You got 1, 2, 3, 4. You have got 4 significant numbers in this digit. Yeah, check out your book. Look at those examples. You can put zeros in front. Let me just go ahead and do that. You can put zeros up here and it will not change. These zeros here, even if you would move the decimal point, oh yes, now it changes. I can't move the decimal point. I have to let the decimal point there. So this still leaves you with 4. These are not counting. Now, the next rule is sometimes a number will end with 1 or more zeros followed by a decimal point. In this case, the zeros before the decimal point are significant digits. So anytime your number ends in a decimal point, anything in front of that is important. So if I say 200 decimal, yes, there are all 3 counting. If I got, let's think of another number. I have 10, and I have the decimal point there. Automatically, there are 2 significant numbers. You have to count both of them. Now, this last one really gets you confused if you're not careful. Any number without a decimal point, zeros to the right of a non-zero digit are not significant. Now look, it says any numbers after a counting number to the right, if there is no decimal, are not significant. So, let me back up here and start here. If I erase this decimal point, and now I have this number here, this 0 is not important. Any zeros to the right, so only one. I only have 1 significant number now. And if I come back here, I'm going to do the same thing. I'm going to erase the decimal point. And now these zeros are not significant. I no longer have 3 significant numbers. I only have 1 significant one. This guy here, the counting number, so I only have 1. Yeah, if I would keep doing that, that last rule can throw you for a loop. So if I would erase these guys here, I would have these guys here wouldn't count. Now if I put the decimal back here, they do. But if I erase the decimal, I only have 2 numbers here. So this one is 2. Yeah, read your rules numerous times so you understand the ones that are significant and the ones that are not. So now, are you ready to do a little board practice before we do your work? You take this number here. I'll take number 1 up here at the top. And you have a whole string of numbers. Okay, the first rule is, does someone know how many significant numbers there are? You look at that and you give me an answer. 3? No, there's more than 3. 1, 2, 3, there's more than that. Someone else got an answer? 5. You got it. 5. Now, how did you figure that there were 5 significant numbers? Okay, one of the rules is any numbers in front are worthless. So we didn't count those. But anything behind the decimal point, you gotta also have a counting number. So you got 1, 2, 3, 4, 5. That's how you came up with 5. The zeros behind the counting numbers you have to count. But the zeros in front are worthless. So don't let the decimal point fool you. Okay? Let's drop down to this guy here. 509,800. How many counting digits do you have in this number? 4. Right. How'd you come up with 4? Okay, let's see how you came up with 4. You looked at this number here. He said it's a counting. Because this zero is in between, you counted it 1, 2, 3, 4. And any digits behind that, there's no decimal point. They were not counting digits. Okay? Let's drop down to this one. 503.60. Now that decimal there is crucial. How many counting digits do you have in this number? Well, you start out and you go 1, 2, 1, 2, 3. I know I count this one, that's 4. Would I count the 0 too? Yes, all zeros behind the decimal point are counted. So that makes me 5. Someone quickly get this. Are you getting the hang of it? Are you feeling? Okay, any zeros in front? No counting number, there's no value. So I have 1, 2. Is that simple enough? Now, get ready. The last 2 are trick ones. How many significant numbers do you have in 7,000? I'll give you a hint. There is no decimal point. No decimal point. So how many counting numbers do you have? This is a tricky one. Watch out. Oh yeah, you're right. 1. You see, these are only placeholders. You only have 1 significant number. Alrighty, let's go to the last one yet. I'll give you one more yet before you start your work. 400 decimal 1. Oh yeah, 1. No. Can't be because you have the decimal. When you have the decimal, that means you'll have to count these guys also. So there are 1, 2, 3. 3 significant numbers there. That doesn't make sense. When you look at the 7,000, you think you should have 4. You look at the 400, you think you should have, well, 3 again, I guess. But the decimal point is the key to whether you count the zeros or not. Yeah, that's all I have for today. If you have any questions on any part, give me a call. I do want to tell you that in yesterday's lesson, lesson 2, I will give you the answer for just a couple problems to check your work. If you did the second part from numbers 5 to 9, if you got that correct, your total interest on number 9, so it would be 9B, would be $84.93. Let me erase some stuff here. $84.93. Number 9, 9B is $84.93. If you got this one right, you know all the rest are correct. And now let me give you the answer for number 18. I'm on page 7 of be back on lesson 2. 18, the total interest again. For that one, 18B is $17.16. 18B is $17.16. That would be your B's answer. So that should tell you, if you missed this one, then you've made a mistake somewhere back up to the top. Enjoy your day.